Hello, students, and welcome to today's lecture, which is going to be on aldehydes and ketones. Okay, and aldehydes and ketones are going to be part of a group that's known as the carbonyl group, and these are the compounds that are the ones that have that double bonded oxygen on them. Okay, and then just a reminder that for the carbonyl groups, that if we have a primary one, that this one's called the aldehyde, and then our if we have one that is not a primary, that this one is called a ketone. Okay. So just remember that for aldehydes and ketones, the main difference is whether it's on a carbon all by itself or if it's on a secondary carbon that's known as a ketone. Okay. And it can only be on a secondary carbon. It can't be on a tertiary one because we can't get a double bond on that carbon. Okay. So this set of reaction spectrum are going to be based off of just the aldehydes and ketones. And just as a reminder that the general way that we do make aldehydes and ketones is that we typically oxidize an alcohol in order to do this. Aldehydes can be oxidized from a primary alcohol, and ketones can be oxidized from a secondary alcohol. And again, tertiary alcohols cannot be further oxidized to form aldehydes and ketones. Okay. The first type of reaction that we can do is that we can go ahead and do a reduction of the carbonyls. Okay. And the reduction of the carbonyls are primarily done with strong reducers. So for instance, this is sodium tetrahydroborate, okay, which is this one right here. Notice that it has this hydrogen at the end. This hydrogen at the end really is one of those cases where the hydrogen actually has a negative state. And remember that often whenever we consider hydrogen as a molecule that we add to things, we normally consider it as a plus state. Okay, so its oxidation state is normally plus. In both of these molecules, the hydrogen has a negative state. Okay, and these will go ahead and addition of these will go ahead and help us reduce either of our that's aldehyde or ketone into the corresponding alcohol. Okay, so that's what's going on here. That these two molecules, when they're added to our carbonyls, will reduce it back down to an alcohol. Okay. Also, carbonyls can undergo nucleophilic addition. Okay, so we haven't gone over a lot of molecules that can undergo or talk about nucleophilic addition all too much, but carbonyls are going to be one of those that's able to easily do it if it's under acidic conditions. And the idea is that we're going to go ahead and take a nucleophile. And in this case, we're going to continue to use our cyanide ion as our nucleophile. And the nucleophile can go ahead and add itself in. It can go ahead and instigate the reaction, cause the electron to move over to the oxygen. Okay, and then the oxygen will have a temporary positive charge. And then if we have it in acidic conditions, it'll go ahead and grab onto that hydrogen ion, and then we'll go ahead and make a nucleophile, and we will have also made a new addition to our main carbon chain. Okay, so we have essentially taken a carbon and we have added a new thing to it. Okay, remember, we can only really do an addition if we are adding something to it, usually to a double bond. So carbonyls, both aldehydes and ketones can help facilitate this nucleophilic addition. And that's really going to be the only reaction that we're going to be talking about here, because the next part is going to be us talking about like the actual testing for aldehydes and ketones. So let me just go ahead and verify what our... And we have a whole separate day set apart for that. So today's a pretty light day, and I hope that this video meets you well, and I hope you all, stay lazy.